them together to make new things. There we go. All right. They're a little behind over there, I guess. All right, so chemical reactions. The process by which the atoms of one or more substances are rearranged to form different substances. It's also known as chemical changes. All right. Oops, did I go too fast, too far? Okay. All right. So what is some evidence that we've gone through a chemical change or a chemical reaction? There's a temperature change. That might be one piece of evidence. And that temperature could either go up or down. Okay. So it forms heat, like a fire, forms light, like a well, your light in your, like this light is not a chemical reaction. This is just electrons getting all excited. The light in your light bulb is not a chemical reaction. It's just resistance to flow in the tungsten wire, if you want to talk about an old-fashioned light bulb. But like a fire, that would be a chemical reaction. Okay? It absorbs heat, which means that it's going to feel cooler. So those ice packs that they have in first aid kits, those are an example of where it's absorbing heat from the outside and it's storing it in the chemical bonds. And so because of that, it's pulling heat from the outside system, outside surroundings, storing it in those bonds. It feels colder to you because the heat is being removed from that area. A color change can sometimes be an indicator. An odor, you're baking cookies or you're baking a cake. Appearance of a solid, which we call a yes, there. Precipitate. There we go. I think I spelled it right. Remember we did those first semester? We did some labs with those.
Yes.
Oh, how quickly we forget.
Go over first semester real quick.
Review. Oh, yeah.
All right. So our starting substances, the stuff that we begin with, are called our reactants. And the stuff that we finish with is called our products. An arrow is used to separate those reactants from the products. So the arrow is read as reacts or to produce or yields. I can never spell yield right. Is it Y-E-I or I-E? I-E. Okay. So that when they're talking about yields, they're talking about stuff that's being produced. So a lot of times, like farmers will say that they have crop yields. You know, we're heading back into our ag thing from our video, tying everything together this morning. So that's a yield. They'll also talk about yield being like in stocks and bonds. They'll talk about like yields, the stock yields. It doesn't mean slow down and proceed with caution like in the driving world. Okay. This is actually produces, which is it's kind of interesting, the different meanings of words. All right. Remember your diatomic atoms when we're doing these, okay? Anytime that these guys are alone, okay? Anytime they are alone, you have to have a 2 by them. So remember that we call these the Brinklehoffs. It's just an easy way to remember all of them. But there are those 7 elements that when they're found in nature in a pure form, they'll always hook up with something else. And the reason why they do that is because they have a very high electronegativity. So they just don't want to be alone. So if they don't have something to react with, they're going to grab a partner, and then that's going to end up creating the Brinklehoff. All right. That will get a lot of people when we start writing down, like if I was talking about how we're going to take water and split it out. People will oftentimes write this down for their equation, and that's not right. Okay, because these are both Brinklehoffs. So when they are in their pure, form, you've got to have 2's down here. And then we're going to talk about how to balance these with coefficients coming up later today. Okay.
What? One oxygen, right? Is it stolen?
I've got it balanced. There's 2 here, and there's 2 here.
Okay.
We're going to talk about how to balance things coming up, Corey.
Okay, that's good.
I'm getting ahead of you. Okay, so you also, with a lot of these, you have to indicate what phase they're in. When we have a solid or a precipitate, remember precipitate and solid is the same thing. You're going to write an S there. In some books, you will see that written as PPT, but I don't typically do that. First of all, it takes up too much room and too much time. But just realize that that's sometimes written that way. Liquid, and I usually use, you don't have to, but I typically will use a cursive L so that it doesn't get confused with a 1. Okay? You can do whatever you want, but I usually use a cursive one. And then mixed with water is AQ. It stands for aqueous. Well, you've heard of like an aquatic center, right? Aqua is water, okay? And then G for gas. All right.
Do you have like the home board?
I saw him with a unicorn.
I don't even swim. I know how to swim. I don't swim because I hate water. I hate water.
I don't like juice.
Juice? I will see.
All right. Let's get done digressing. You ready?
Oh, my sugar.
Okay, so there are word statements, and these are typically what I will give you, and then you have to know how to write the formulas because that's what we spent a month or so on. Okay, and we'll even get to the point where I'm not going to give you this part. You have to know what's going to happen when these 2 things come together, and I'm going to show you how to do that too. Okay. So these word statements then are going to be used to indicate the reactants and products. We have our phases on here. We don't always put phases on, so don't expect that as a hard and fast kind of rule. Skeletal equations then are going to use chemical symbols instead of words to indicate your reactants and products. So for example, here we would have Fe, we would have chlorine, but how does chlorine have to be written? Cl2, right? And then that's going to make iron 3 chloride. Okay. And then I'm going to have to show you how to balance this. This is not balanced right now. All right. So chemical equations then show that matter is conserved in a reaction. The skeletal equations are going to lack that information. So for example, Corey was saying, you know, we've got 2 here. Over here, we've got 3. How did we create that new 1? Okay. We didn't. We just don't have the thing balanced yet. So they're going to accurately represent a chemical reaction by an equation. So we're going to use an equation to make that happen. And it shows the conservation of mass or matter, whichever one you want to think about, law. Okay, so we are going to show the number of atoms of each reactant and that it is equal on both sides of the arrow. If it's not, it is wrong. All right, so to balance an equation, you must first find the correct coefficients in the chemical formulas in the skeletal equation. Once you have that skeleton equation written like this, you cannot change these subscripts, okay? These subscripts are what they are. You cannot modify them. I can't go and go, oh, I'm just going to change that to a 3. Or I'm just going to change that to a 2. You can't do that. It's not allowed. Don't think about it. Don't touch it. Once you've got these things written out, you don't touch the subscripts. The only thing you can use is coefficients. And those are written out front here to get the thing to balance. Do not touch subscripts. Got it? Good. All right. So a coefficient is a chemical, in a chemical equation is written in front of either the reactant or the product. Oh, you cannot put coefficients in the middle of formulas either. Okay. So I can't take this and go, oh, I want to put a 2 in here. Okay.
That was terrible.
You can't do it. Don't even think about it. Okay? You can't just go and randomly put a number in between that formula. Once this is written, the only thing that you can do is coefficients out front. I've had it all, Corey.
Oh, that's not good.
Coefficients in a balanced equation represent the lowest whole number ratio. Okay, I will take points off if you balance these and don't have it that way. Okay, so if you have 4 here and 12 or 6 here and 4 here, okay, this is balanced, but these are not in the lowest whole number ratios because everything can be divided by 2. So make sure that you're careful with that because I don't mark the whole thing wrong, but I do take points off. All right.
I can't hear it, honestly.
So steps for balancing. You're going to write your skeletal equation. So here's my skeletal equation from above. That way I don't have to keep going back and forth. Okay. I am going to count the number of elements on the reactant side and the number on the product side. When you're getting used to doing these, draw a line, hopefully better than that, between your reactants and your products so you can tell the difference. And then you're going to do an inventory. So I've got Fe and I've got Cl over here. Now, if these do not appear in the same order as over here, write them in the same order. Write them the same way that they appear on this side. If you've got different ones over here than you have over here, you did something wrong. Because you can't get rid of or create new things on the other side. They have to be the same elements. They're just getting rearranged. You're just taking the set of blocks and building a new castle. Okay? Once you're done with that, count how many of each you have. Over here, I have one of these, and I have two of these. Over here, I have one of these, and I have three of these. All right. I can't go up and just change this to a 3. I cannot touch these subscripts. Naughty, naughty, naughty. Don't do it. All right. So these here are not balanced. So I am going to look for the lowest common multiple between 2 and 3. 6. Now, I will also tell you that even and odd, typically you want to double the odd. So I'm going to start, since this is the odd one, I'm going to start here. So I'm going to put a 2 here. That brings that up to 6, but it messes with this guy as well. Okay, we are distributing this throughout. So 2 times 1 is 2, and 2 times 3 is 6. All right. So now I need to go over here and fix this. So this was my problem child, so I'm going to attack him first. Yeah, I named him Bone. This one's called Nick. Okay, so 6, I need to make this into 6. So what do I put out here? 3. Okay, so now I've got that up to 6. So that's balanced. Now I need to deal with this guy. What do I need here? 2. And now he's balanced. And I go back and I check my inventory. If everything is balanced out, we are done. Okay. Go back and double check and make sure that it's in the lowest possible ratio. If it's not, you need to go back and reduce. And sometimes it happens. Okay. This isn't on there anymore. We don't use a book. So count polyatomic ions. Hence, count polyatomic ions as the same unit if they're not changed on one of the sides. So if they're unchanged, keep them on both sides. And you have a list of those polyatomic ions on the back side of your periodic table. Leave uncombined elements until the last. That's what we did over here. We left these to the end. Hydrocarbons may need to be doubled, and I will teach you in a couple days kind of a hint on that one. It doesn't work all the time, but it works about 95%. And then water can be written as HOH. And that comes in handy when you've got like KOH over here, and then on this side, you've got water that's formed. Because if you write this as HOH, now you've got that polyatomic identified on both sides, and sometimes that can help you with balancing. Okay? All right. Oops, I didn't mean to do that. All right, so let's practice here. So again, you write your inventories out. So I've got HG, I've got O, HG, and O. And then I do my counts. I've got one of these, one of these, one of these, and 2 of these. All right, so I need to go over here and deal with this oxygen. I cannot squeeze a 2 in between here. Don't even think about it. I can't change this subscript. Don't think about it. All I can do is put a coefficient out front. But if it changes my oxygen, it's going to change my mercury as well. So then I come back over here. I put a 2 here, and that takes care of mercury. Any questions on that one before we move on to the next one? All righty. So this is one of the ones where we have polyatomics on both sides. Okay. I have sodium here. This is OH. And if I think of this as HOH instead of water, I have OH over here as well. So it's unchanged then. I have hydrogen. And then my sulfate is the same on both sides. So I'm going to keep it together. Now I'm going to do an inventory. I have 1 sodium. I have 1 hydroxide. How do I know that I only have 1 hydroxide? If I had more than 1, what would I have here? If I had this, I'd have to have parentheses around the hydroxide, right? I don't, so I've only got 1 of them. How many hydrogens do I have? 2. And how many sulfates? 1, because if I had more than 1, I'd have parentheses. All right, we're going to go over here and count these. Over here, how many sodium? 2. How many sulfate? 1. Now notice that I wrote these in the same order, even though they're in different order over here. I wrote them in the same order on both sides. It's easier for your brain to compare this chart if you write them that way. All right, how many hydrogens? 1. And how many hydroxides? 1. All right. I'm going to start with my sodium, just because I am. No real random reason, just first on the list. So I'm going to put a 2 here. That's going to give me 2 NAs, and it's going to give me 2 OHs. And then that means that I need to deal with this guy. So how am I going to deal with him? Where? Okay, so if I put a 2 here, now I'm going to have 2 H's, and I'm going to have 2 OH's, and now it's balanced. Do you see how writing that as HOH made that a lot faster to balance? And if you are balancing and keeping these polyatomics like that, that makes it easier too. Otherwise, you'd have to add these oxygens up, okay? And so because of that, it's going to make it much faster to balance this. All right, see if you can do the next one. So you got all your homework done already, Ben?
What?
Oh, nothing.
I've been very busy. I have.
Oh, you have?
Hush, child. I did homework that Thursday night for 3 hours because I was very busy. Yes. And I did on my packet, so I could.
Mm-hmm.
Oh, you punch.
You just like
I know. What comes back?
All right, how we doing? Need more time? Done with this one?
I'm a CR04.
Yep. The CrO4 is the same on both sides, so keep it together. The NO3 is the same on both sides, so keep it together. I'm going to do my inventories now.
Do we do anything about the subscript? Never mind, it's right there. Okay.
Okay, the subscripts. No.
No. I meant like the two outside of the no three.
No.
Okay, never mind.
So the NO3, because this is in parentheses, that means that we're going to have two NO3s here. Okay. I got my 2 potassiums, and then it should be pretty easy to see that this is where the issue is. And if I put a 2 here, that's going to resolve everything. Good. Now, these inventories down here are like training wheels. Once you are comfortable balancing these equations, I still use them once in a while, okay? But once you are comfortable working with these equations, you don't have to do these inventories anymore. It's completely up to you when you pull the training wheels up. Again, there are some times that I still use them, okay? And I've been doing this for, let's not talk about that. All right. You got this one done yet?
25 years.
No, it's been longer than that, honey.
Well, that's when you've been teaching them.
Yeah. All right. Well, this one's kind of a mess. I'm going to start, I think, with my SO4s. Okay. And a lot of this is just gut feeling. Like I've just done these for so long. So I can't really tell you why I'm starting there. I just am. Okay. So I've got SO4 over here. I've got 3 of them. So I'm going to go over here and I'm going to do a 3. That's going to affect my SO4s. It's also going to affect my hydrogens. Then I'm going to come here. I'm going to work on my boron. So I'm going to put a 2 here. So it takes care of my boron, but it's also going to bring this up to a 6. So I've got these 2 things taken care of. These I need to be at a 6. So if I put a 6 here, then that's going to take care of that. That'll be at a 6 and a 6. And we are good. Is that making sense? All right. All right. So what you are going to do is 9-1 for homework. We need to talk about types of reactions. Do I have time for that? Yes. Okay. So a synthesis reaction. Synthesis. We're going to do some of this together so I can show you what these mean. A synthesis is like a marriage. You're bringing 2 things together to make one thing. So this is a synthesis reaction. Okay, let me find a decomp here. Decomps are easy to identify because you start out with one reactant. It's the only equation where you only have one thing. So if you don't have a plus sign on this side, you just have one item here, it's always decomp. And that's like divorce. Okay? So you're taking 2 things that were one and you're breaking them apart. So synthesis is like marriage, and decomp is like divorce. Okay? All right. The next type is called single replacement. Single replacement is like guy and girl are together, right? And another guy comes along and she dumps him or the other guy.
Oh.
Okay? Oh, just wait. No, wait. It gets worse than that. Okay? So this is a single replacement. Do you see how sodium kicked hydrogen to the curb?
Yeah.
Okay? It replaced hydrogen. All right? So that's called a single replacement. Here is double replacement. Okay? So metal is going out with non-metal. This metal is going out with this non-metal. And they swap partners. So that's like a Jerry Springer, some sort of, yeah. Okay. No, he's my man. No, he's my man. No, you stole him. No. How dare you? Dr. Phil, okay. No. All right. So this is double replacement done. Okay. So this is double replacement. Do you see how they're swapping partners? Okay. So double replacement. So that leaves one thing on here. And the one thing is combustion. And what you have to look for in combustion is oxygen as a reactant. So if oxygen is a reactant, then this could also be a combustion reaction. So there's two answers for that one. This one is combustion. Okay, because oxygen is a reactant. Can you find another one on there where oxygen is a reactant? What number? 10. Okay, so this is also a combustion reaction. It's also a single replacement, so you can get two answers right there. All right, now this is going to have you, and there's one on here where I'm not having you identify what it is because it gets weird. But this is going to practice some of your skills, hopefully, of being able to write formulas. Now, I will tell you, for a lot of these, if you don't write the formula correctly, you will never, ever get the thing to balance. You will just be spinning in circles and it's never going to balance. So if you're having trouble balancing these, go out to the internet and check and see if you have the formula written right. Because if you don't have the formula written right, it's not going to balance a lot of times. Sometimes it will. Not always, though. Okay? If you're having trouble with one of these, erase what you've got, walk away for a minute or two, and come back to it. Sometimes it's the best way to get these to balance. You'll see what's wrong. You just need to take a break. Okay? So this is due tomorrow. There's only 20 problems. And I've done a quarter of it for you already, right? You're like, yeah, it's not a quarter, Lippy. That's less than a quarter. You did the easy stuff. All right, so see how you do on this. We will meet back tomorrow and talk about it. Make sure you do these in pencil because you will have erasures. So pencil is your friend.